Okay, we're going to solve the following quadratic equations by factoring. So the first equation is already in expanded form, so we want to write it in factored form. This is three terms, so we're going to try binomials equaling 0. So we got x times x to give us the x squared. Factors of negative 21 that add to negative 4 is negative 7, positive 3. So then once we have factored form equaling 0, we're going to solve each factor equaling 0, so x minus 7 x minus 7 equals 0, or x plus 3 equals 0. So solving each one, adding 7 to both sides, we get x equals 7, or subtracting 3 from each side, x equals negative 3. So we get our two answers of x equals 7 and x equals negative 3. Okay, for this next one, we want to write the equation equal to 0, so we'll just add 8x to both sides. We'll end up with 3x squared plus 8x equaling 0. So once it's expanded, we can factor it right in factored form. Notice there's a common factor of x, and if we take an x out, we're left with 3x plus 8 equals 0. Once it's factored, we can set each factor and solve each factor equal to 0. So 3x plus 8 equals 0 and x equals 0. So x equal to 0 is one of my answers. And then solving here, we have 3x equals negative 8. Dividing by 3, we get x equals negative 8 thirds. Sorry for that. X is negative 8 thirds. Okay, so for C, I just want to move this down a little bit. For C, again, we want to write everything out in expanded form. So we'll expand 9a squared minus 27a equals 3a minus 25. We'll set it equal to 0 by moving all the terms 3a and positive 25 to both sides, or to each side. So I'm going to subtract 3a and then add 25. So putting this in standard form, we get a 9a squared minus 30a and then plus 25 equals 0. So we have expanded form equaling 0. We want to factor, and we notice when we factor this, it actually factors to a binomial squared. We have a perfect square trinomial. If you look at the first and last terms, this factors to a 3a minus 5 quantity squared, and that's equal to 0. So if we set the factor equal to 0, 3a minus 5 equals 0, and then we basically get a repeat of that factor. So since it's squared, when we solve, we get a equals 5 thirds, so adding 5 and dividing by 3. And this a equals 5 thirds would be a repeated solution. So again, we'll talk about the repeated, or why it's repeated. Our factor is squared, so we get two of the same values. All right. For D, again, we want to expand and set equal to 0. So we want this in expanded form, so we'll distribute p squared plus p, and then we'll subtract 6 from both sides. Minus 6 equals 0. So we have expanded form on the left equaling 0, so if we factor this to two binomial factors, we get p and p. Plus 3 and minus 2 would give us a positive 1 in the middle. So 3 times negative 2 is negative 6, and then 1. Set each factor equal to 0 and solve. So p plus 3 equals 0, or p minus 2 equals 0. So solving, we get p equals negative 3, or p equals positive 2. We get our two answers here. I'm just going to scroll down again to get to the last few problems here. One thing we notice with E is that this is factored form, and it's already equal to 0. So this is exactly what we want when we're solving. From here, we can just set each factor equal to 0. In solving, we get 2x equals -1, or x equals -1/2, or 3x equals, if I add 7 to both sides and then divide by 3, x equals 7/3. So we get our two answers, and that's just noticing right from the start that we were in factored form. We don't have to do anything to that. The next problem, F, you notice we're in factored form again, but it's equal to -30. So it's not in the form that we want to solve, so we want to write this in expanded form. So we want expanded form equaling 0. So if I expand the left side, I get a squared. Plus 8a minus 3 is plus 5a, and then minus 24, and that equals -30. Setting equal to 0, we'll add 30 to both sides, and we would have on the left side a squared plus 5a plus 6, so -24 and 30 is 6, so that's equal to 0. So this is expanded form equaling 0, so now we can factor. We'll try two binomials again, equaling 0, so we have a and a. Factors of 6 that add to 5 would be plus 2 and plus 3. If we set each factor equal to 0 and solve, a plus 2 equals 0, or a plus 3 equals 0. So a equals -2, or a equals -3.